Hi, today I'm going to use induction to prove that the sum from I equals 1 to n of 1 over I times I plus 1 is equal to n over n plus 1. So let's begin with our inductive statement, which is P of n. That can be written as I equals 1, n 1 over I times I plus 1 equals n over n plus 1. This is our inductive statement, which is our very first step. So let's get into our base case, which is the simplest case we have. We can assume n is equal to 0. So now we have to find what p of 0 is. That is equal to I equals 1, 0, 1 over I times I plus 1 is equal to 0 over 0 plus 1. The left-hand side, since the upper bound of the summation goes to 0, we know that the entire left-hand side goes to 0. So this gives us 0 equals, and the right-hand side is 0 over 1, which is 0. So the base case holds true. So now, we've proved that our base case holds true. Let's move on to the inductive hypotheses. This is our next step. We take arbitrary k belongs to n. So we take an arbitrary value k that belongs to natural numbers, and we assume pk is true. So what is pk? Pk is essentially just I equals 1 k of 1 over I times I plus 1 is equal to k over k plus 1. So that is pk. So now that we're done with the inductive hypotheses, let's move on to the inductive step. The inductive step states that assuming pk is true, we want to prove that p of k implies p of k plus 1. This is the basic step in induction. We just have to prove that if p of k is true, then p of k plus 1 is true. And a really important note about the inductive statement: never quantify in the inductive statement. Never write for all n. This will lose you points. The reason why we don't write for all n is because that's what we're trying to prove. If we write it in our inductive statement, then what's the point of our entire proof? There's no point. That's why we never quantify in the inductive statement. So now let's move on to the inductive step which we were doing. So what can p of k plus 1 be written as? So we want to prove the right-hand side of p of k plus 1 can be written as I equals 1 k plus 1 1 over I times I plus 1. And this can be written as, it can be split into two parts. So I equals 1 to k of 1 over I times I plus 1 plus 1 over k plus 1 times k plus 2. So how do we get to this? We first split it into I equals 1 to k. This takes care of the first k elements of this summation right here. And then we're left with the k plus 1th element, which we plug into I and get this right-hand side. So now we already know what this part in blue is using the inductive hypotheses. So now all we have to do is prove it. So using the inductive hypotheses, we know we can write it as, or like we get k over k plus 1, because we know it from right here, this section right here, plus 1 over k plus 1 times k plus 2. So now you can simplify this and you'll end up with k squared plus 2k plus 1 over k plus 1 times k plus 2. And this is equal to k plus 1 over k plus 2, which is exactly what we wanted to prove, as p of k plus 1, in fact, should be, as per our inductive statement, k plus 1 over k plus 2. So we've proved that it's true. So p of k implies p of k plus 1. Since k was arbitrary, we conclude for all n belongs to n, now we're quantifying. I equals 1, n of 1 over I times I plus 1 is equal to n over n plus 1. Hope you enjoyed this induction proof. Thank you so much.